Okay, we've got a word problem here, and it says that your child's going to need $13,000 when he turns 16, and maybe he's trying to buy a car or something along those lines. So, and we're told that the rate of return on the investment is going to be 14%, which is a really good return over a 16-year period. But anyway, a key component here is that the interest is compounded continuously. The question says, how much money do you need to place in the account when your son is born in order to have $13,000 whenever he turns 16? Okay, and then we need to round it. Well, continuous, compounded continuously is a key component here. That means that we're going to use our compound formula, compound interest, but we're going to use the continuous compounding interest. And that equation is down here. This is our amount. At the end, this was our initial amount, the number E, and then the rate times the time. Okay, so now what we're going to do is start plugging these in. Okay, so this is the amount after a given period of time. So this is going to be our 13,000 here is going to be our A value. Our P is our initial principal, and that's the one that we're solving for. We're unsure what P is at this point. But we know what our rate is and we know what our time is. Our rate is going to be a 14%, and our time is going to be 16 years. So I'm going to kind of fill in our information here, and you see that up here. 13,000, that's how much we have to have. And it's going to be after 16 years, and the rate is going to be 14%. Remember, we convert it to a decimal. With a decimal, remember that we just move it over 2 spaces. So the decimal was at the end of the 4, and we move it back, and it becomes in front of the 1. Okay, so now that we have this one here, we've got our equation here. We're going to solve for P. We're trying to find out what the initial investment is going to need to be. So what we do is we plug this part here into our calculator. And the reason why we plug this part here into our calculator is because it's P times the number E all raised to the 0.14 times 16. So we're going to plug that one in, and then we're going to get P out by itself. So let's plug that section here into our calculator. I'll pull up my calculator here. And this will work on any of your TI-83 or TI-84. Any of those are just fine. Let me clear out what's in there now. Okay, so I've got E to the 0.14 times 16. So I do that. And E is this button here right above the LN. But it's in blue. That means that we have to click the second button. So I hit second LN, and that gives me my E, and it automatically raises it to the exponent place. And that's where we want right here, 0.14. And you can type in 0.14 or just 0.14. Either one is okay. So 0.14, and I just use parentheses just like it's showing here, times 16, and I hit enter, and the enter on that gives me this number 9.3933 on down the line. And I typically don't recommend that you round any of those until the very end. It will ensure that you get the right answer. Okay, so we've got that number here, so now I'm going to fill that in here for my E. Okay, so I'm going to go back to this button, to this equation here, and I'm going to fill in what I know. E to that, E to the 0.14 times 16 equals this. Now, typically you're used to seeing this number written in front of the variable, and that's where it should go. I only left it here just to illustrate that that's where that number came from. Okay. Alright, so the next thing that we're going to do here is I'm going to divide both sides by that number. Okay, if I'm going to divide both sides by that number, I will get P all by itself, and P is the value that we're looking for. So now I'm going to divide both sides by that. So I pull back up my calculator here, and okay, there's my calculator. I type in 13,000. And I can just go divide it by 9.3933, or I can hit another shortcut is if you hit second answer. Now, whoops. Let's go back here and let's clear that out. I have to hit 13,000 divided by, then I go second answer. And whatever this answer was previously, that will automatically populate here. That way it saves you from having to round or get an error there. Then I just hit enter. And that gives me a number 1383.96. So then I go back over here and I just type that in. And there's what I've got here, and that matches what I had over here for my calculator. So I'm okay there. The last step that I have to do here is it says round your answer. And I look up here and it says round your answer to the nearest dollar. So if I'm going to round this one to the nearest dollar, that'll be $13.84. So $1,384, if I put that away into the account, then when my son is born, whenever he is 16, I will have $13,000 in there. And that's an important piece of continuous continuously compounded interest, or any interest at that point, is $1,300 if you can invest it. Over a 16-year period will grow to $13,000. It grows quite a bit. And so that's kind of where we're getting at with all of these, is the more money that you can put away now and let it sit there and grow for you, the amount of money you will have in the long run will be a much larger amount.